Consider the following preference schedule for 5 candidates. Suppose we 5 here. And the candidates are A, B, C, D, and E. And this is called preference schedule or called preference table. And here number of borders 18, 12, 10, 9, 4, 2. So total number of borders here, if you add all them together, going to be total going to be 55. Okay. So first question: if candidate C withdraw from the election and votes for the other candidates were moved up in the table, after we withdraw, you move other candidate up to the table, how many votes would the other 4 candidates receive? Okay, so what happens is C going to be removed here. C is withdrew, that's the removed here. So only have a 4 choice going to be. And so let me completely remove those C. Okay, so now you move the candidate up. So B going to be now 4th position, A going to be now in 4th position here in this column, and B going to be 1st position in this column, and E going to move next, D going to move next, and A going to move next. So how it looks like is this. This is the B, they're going to be moved to top. This is going to be A here, this A moved to top. So now this B moved to top here in place of C, and now B position you move E up. So now order going to be B, E, D, A. That's what the order looks like. Here, this position E going to be moved up, so going to be E here in the 2nd position, and this E position going to be B, and this B position going to be A. Okay, so that's how you move everything up. Now this is going to be A here. Now here E is in 1st position in the last column. Now this is going to be D, this is going to be B, this is going to be A. So pretty much 5th column is gone here. Okay, that's how you move the candidate up. So here. Okay, so that's how you move the candidate up. This is no longer, we have this column going to be. So you have only 4 choices here. So the question is, who going to win the election, or how many votes would other 4 candidates receive? So A got, let's say how much A got as the first choice here. A got 18 as the first choice. A got 18 votes. And B got, let's see how many B got. B got 12 here as the first choice, and 10 as the first choice, and 12 plus 10 was going to be 22. And D got only 9. You get 9, and E got 4 here as first choice, and 2 as first choice. It's going to be 4 plus 2, which is going to be 6. So who get most votes is B. So B got most votes. So who win by the plurality method? The answer is, who win by the plurality method? That's the B win the plurality method. Then is that the majority? No, it is not, because out of 55, to get the majority, somebody should get 27.5 or more. That means should get 28 or more for majority, right? But B got only 22, which is not the majority, but this is just a plurality. So that is called plurality method. Whoever get most first place votes is the winner by plurality method. Alright, next question. Suppose this 4th state decided to create the legislature with 100 seats. I should change to 100 to 101. Okay, it's the similar, but I want to change to 101 seats. This is the number of quota. In other words, we want to divide this 100 quota among this 4 group. That's what we want to do. And first question is find the standard divisor. That's the first question. I mean, first part of the question. Second part of the question is find the standard coda for each state. Okay, that's the next question. Find the standard coda for each state. And the last question is find the seeds for each state using Hamilton method. So we have to divide this 101 seed among this 4 group using Hamilton method. We have to use Hamilton method. So to do Hamilton method, we have to find first standard divisor. So to find the standard divisor, you have the formula. I should say SD as the standard divisor is total population divided by number of coda, also called number of seat here, 101. But what's the total population? If you add all this number, all the population, you get total population, which is going to be 10,000. So total population is 10,000 divided by number of coda is 101. And if you divide 10,000 by 101, and then you'll get 99.0099. And more, I just keep up to 4 decimal places that as a standard divisor here. Okay, it's better if you keep more decimal. That is accurate if you do the standard coda or Hamilton method. So I use 99.0099. Now this is the standard divisor, SD. And now to find the standard coda for each state, you have to divide the population by standard divisor. So you divide 936 by 99.0099. So let's find the standard coda, STD standard coda for A. Let's do for A first, right? So to find A, you divide 936 divided by 99.0099 for A. Okay, that's how you do. What is that going to be? So if you divide these two numbers, you get 9.454. Again, instruction tells you how many decimal places you rounded here. It doesn't tell you here, but I rounded to 3 decimal places. This is called standard coda for A. Similarly, to find the standard coda for B, divide 2726 by 99.0099. You get 27.533. And if you divide this 2603 by standard divisor, you get 26.290. Okay, and if you divide 3735 by standard divisor, you get 37.724. Okay, that is called standard coda. I answered the second part. Find the standard coda of each state. That's how you do. Now next is find the seats for each state using Hamilton method. So to find Hamilton method for each state, you got to find first minimum coda, minimum, minimum coda. Minimum coda gives you from here. You always round it down. It's going to be just 9. And this is going to be 27. Doesn't matter, 0.53. After decimal, you have 0.53. You never goes up. You always round it down. Like that's called minimum coda. It's 27. This is going to be 26. This is going to be 37. Okay, that is minimum coda. Now, if you add this all the minimum coda, 9 plus 27 plus 26 plus 37, you get 99. You get 99. You get 99. But total number of atom you need to divide is 101, but only 99 is total here. So we call 2 surplus, 2 more. The question is, who will get this 2 more quota? Which state got 2 more quota? So Hamilton says the state which has largest fractional part or largest decimal part gives the quota one at a time. So which is the largest here? Largest is let's say 0.724. That's the largest one you see here. That's the largest one. Let me just highlight that. That's the largest one. So state D got 1 more quota. So you add +1 in state D quota. Now second largest is going to be the B, which is 0.53, and you add +1 for the B. So now A got 9, B actually got 28, C got 26, and D got 38. So that is called final apportion using Hamilton method. This is the final apportion using Hamilton. So this is the final answer. If you add all them total, you get 101. Okay. Next question. You need a loan of 100,000 to buy a condo. Calculate your total closing cost. That's why you got to do first. And the monthly payment, that's what you got to do next. And the total interest paid towards the 30 years fixed rate mortgage at 5% with the closing cost of 1,235 and 2 points. So you got to find 3 things here. One is closing cost, the other one is monthly payment, other one is total interest. 3 things here. So here the loan here is 100,000, gonna call P, and you have a APR. APR here is 5% is 0.05. The term here, the time here is going to be how many years? That's called Y. Y going to be 30 years fixed. And then you're paying monthly. When you get the loan, you're paying monthly. For the bank, what do you get a loan from? So you get n equals 12. It's called monthly. Obviously, we pay back monthly to the bank after you get the loan. So we pay 12 times a year. So you put n equals 12 monthly. So there's a formula for monthly payment first. PMT formula going to be this is the formula. Again, the formula is provided for you. You got to use properly. P times APR divided by N divided by bracket 1 minus 1 plus APR over N to the power negative N times Y. Close the bracket. That's the formula. Again, this formula is provided for you in the test. Use the formula properly. And let's put the P here. 100,000 and APR is 0.05 divided by 12 and divided by bracket 1 minus 1 plus 0.05 divided by 12. Again, I am using this formula here. APR is 0.05 divided by 12 minus N is 12 times Y is 30. So if you use the calculator to find all together, or you can do the top and you can do the bottom and divide, you'll get 536 cents, $80.82. That's the monthly payment. Okay, that's the monthly payment again. So this is called monthly payment. We found the first part of the question's answer. This is the PMT, which is monthly payment. Next question is find the interest. So to find the interest, what are you going to do? How much total payment going to be? So total payment And to find the uh, total interest, you got to find the total payment over 30 years. How much is total payment? Total payment equals to, you pay $536.82 every month times 12 in 1 year times 30. That's going to be total payment over 30 years. You pay for the loan. That gives you $193,255.20. That's the total payment. I don't want to write the dollar for a moment, okay? This is the total payment. So the interest going to be the total payment, $193,255.20 minus the loan that you get. The loan is 100,000. So the difference is going to be the interest. So the interest is going to be $93,225 if you round it to the nearest dollar. I ignored the 20 cents here. That's the total interest payment over 30 years. Next question is, what is the closing cost with 2 points? So the 2 points means 2%. 2 points means 2% of the loan. That cost, closing cost. So 2% means 0.02 of the loan, which is 100,000. That's the loan. That's going to be 2,000. 2,000 is the cost from 2 points. Now also you got to put $1,235 as a closing cost as well. So total closing cost is going to be 2,000 plus $1,235. Okay, that gives you $3,235. That's the closing cost. Okay, the next question, question number 12. All right. So this is about the probability. Find the indicated probability. Okay, 2 marbles are drawn without replacement from the box with 2 white, 4 green, and 5 red marbles. So let me put down here 2 white, 4 green, 4 green, and 4 green and 5 red. And total marble going to be obviously 11 marble. Okay, so you took 1 marble, and again you do not replace it. It tells you draw 1 marble without replacing. You draw another one. So in the question asking for, are those events, drawing white marble and the red marble, independent? Since you do not replace the first marble, they are dependent by the time. So they are dependent. Okay, they are dependent. And if they are dependent, the formula for probability of A and B, I mean this is the first event and second event, equals to probability of A times probability of B given A. Okay, that's the formula. So here probability of A and B, where A represent, in this case, white marble, and the B represent the green marble, red marble. So I'm just rewrite this formula as this way: probability of white and red equals to probability of white times probability of red given white. Okay, this is just a formula, another format. I replace A by W, white, B by red. So that's the formula. So let's find the probability of white. That's what I'm looking for, probability of drawing first marble white and second marble red. See, this is the question, find the probability. that one marble is white and second is red. So that's what I'm looking for here. So what's the probability of white? How many white here? 2 white out of 11 marble. 2 over 11 is probability of white times probability of red given white. How many red here? Yeah, 4 red. Sorry, 5 red. Okay. Yeah, 5 red. But now since you did not replace the marble, now number of marble is going to be 10. So you're going to get 5 over 10 for the probability of red with given white. The given white means first marble drawn is white. So then you have only 10 marble left here. So out of 10 there is 5 red. So 5 over 10 is probability of red given white. So if you multiply 2 over 11 times, oh, by the way, you can simplify 5 over 10 as 1 over 2, and you get 2 over 22, which is same as 1 over 11. That's the probability of white and red. Question number 13. Okay, this is called two-way table. The data in the following table shows the outcome of the guilty and non-guilty plea in 1028 criminal court cases. What's the probability that randomly selected defendant either pled guilty or was sent to the prison? So this is the data here, which data called two-way table, and looks like 392 plead guilty but sent to the prison, and 58 not plead guilty but sent to the prison, and so forth. So to find the probability, you got to find how much plead guilty first. So you got to add this column. Okay, it's a total here. Let's say this column here, and also you got to fit how many sent to the prison, how many do not send to the prison. So let me make a column here. So sent to the prison, you add 392 plus 58, that gives you 450 sent to the prison. 564 plus 14 not sent to the prison, these are 578 not sent to the prison. And how many pled guilty? You add 392 and 564, you get 956. That's guilty plea. And non-guilty plea going to be 58 plus 14 is going to be 72. So 72. So if you add this way or that way, you get total, which is going to be 1028. This is the total number of criminal cases here. That is 1028. So the question looking for, what's the probability that randomly selected defendant either pled guilty or was sent to the prison? So I'm looking for either pled guilty or sent to the prison, or here in the middle. So I'm looking for probability of pleads guilty or sent to the prison, sent to PRISN. So PRISN. So let's say the pled guilty is A. Let's say sent to the prison is a B, and we have the formula probability of A and or B going to be probability of A plus probability of B minus probability of A and B. Okay, that's the formula. So again, A is a pleads guilty or B is sent to prison, and the formula for or, the probability of two events connected with the or is going to be PA plus PB minus probability of Phi A and B. So what is the probability of A? How many A is pled guilty? How many pleads guilty? 956. So 956 divided by total is 1028. That's the probability of pleads guilty. How many sent to the prison? Plus you can see here, that's row 450 total sent to the prison. 450 divided by 1028 minus how many pleads guilty and sent to the prison. And you guys see here this number, which one? 392. See, 392 person sent to the prison and plead guilty both. So you subtract that, 392 divided by 1028. So if you put the calculator and you simplify, you get 0.986. If you round it to 3 decimal places, that's the probability of a randomly selected defendant who either pled guilty or sent to the prison. That's the probability. Okay, question number 14. Next question. Find the expected value. The question is asking for expected value, and you are given 13 to 1 odd against drawing a 2 hard when 2 cards are selected at random from the deck of 52 cards. So but again, you remember that the card is drawn by replacement. So when you draw the card, you replace back. Again, you are betting on the drawing 2 card as a heart. Okay, that means if you win $13, if you win $13, if you succeed, that means if you get both card heart, you win $13. If not, you lose $1. So find the expected value to you of the game, round to the nearest cent. So we got to find the expected value. So looking for probability of both heart. What's the probability of drawing both heart? Both heart. Probability of drawing both heart is going to be probability of first heart times probability of second heart. So probability of drawing first heart is going to be 13 divided by 52 times, again you replace the card back, so again there is 52 card on the deck, and again 13 heart. So 13 divided by 52 times 13 divided by 52, this gives you 1/4 times 1/4, which is going to be 1/16 is probability of drawing both heart. So what's the probability of drawing not both heart? Not both heart. It's like a complement of this is going to be 1 minus 1/16, which gives you 15/16. If you subtract this number, you get 15/16 is probability of not both heart. So to find the expected value, you got to find the table, and we got to create the table. You multiply the probability with the outcome. So here you go. So there's the outcome, and it's the probability, the next column, bility. So the outcome is $13, and the probability of to get $13 is going to be 1/16. Notice that if you get both heart, the probability of both heart is 1/16. That's probability is 1/16, and you get $13. If you did not get both heart, you lose $1. So you do $1 minus $1. So this is the outcome, negative $1 to you when you do not get both heart. So what's the probability of that? Is 15/16. Okay, so expected value, expected value equals to, you multiply 13 with 1/16 plus -1 with 15/16. So basically you multiply the outcome with the probability and add them. So this gives you 13/16 minus 15/16, and this is -2/16. This is same as 0.125 with the negative. So the expected value is -0.125. In other words, if you play the game, such game 100 times, you will expect to lose $12.50. That's what it means. Okay, that's the question 14. 15. Find the area of the shaded region. There's two areas. One is inner circle, or there's outer circle. The area of outer circle is, let's say, area of bigger circle, I could say, bigger circle, equals to pi r squared. the R for the bigger circle radius is going to be 6, so I have to do 5. 6 squared is going to be 36 pi. Okay, obviously centimeter squared, that's the unit. So area of a smaller circle equals to pi r squared again, but the smaller circle has a radius 2 centimeter, you can see here. So pi times 2 squared is going to be 4 pi centimeter squared. So this area of the shaded region, which is this one, outside inner circle, inside the outer circle, is going to be difference 36 pi minus 4 pi. Okay, this gives you 32 pi, and 32, replace the pi by 3.14, and you get 100.48 centimeters squared. That's the area of shaded region.